but maybe you want to dig into a bit more. You mentioned knowledge graphs, LLMs, MCP, and A2A, which you touched on briefly earlier in this episode, but we didn't go into too much detail.
Yeah, it's this is one that I've had a lot of agentic discussions over the last year and a half, and you can define it at a high level, but we thought we'd go a little deeper, and it's important to recognize that when you start thinking about an agent, and here's the why it's in the predictions. There are two different philosophical approaches to what an agent is. There are a cast of characters who think that an agent is a feature of an LLM. The central piece is the large language model, and the large language model has agentic behavior. That might be true. I don't think that's very useful, to be perfectly honest. I think that isn't really a fully exploiting the capability. We, on the other hand, and we are not alone, there are a lot of people who absolutely believe exactly what I'm about to say, but not everybody, that an agent is actually a software system that has multiple dimensions to it, of which an LLM is one of them. And it's in both cases, both groups are saying this should be an autonomous system. It should be able to do work independently. But the difference is it just a feature of an LLM, or is it a software system that uses LLMs and other stuff to accomplish that task? We're in the second camp. And so we drew a little picture that I think has worked really well for people to say, okay, at a technical level, an agent that is that software system actually has four components. One of the components is, in fact, a large language model, and it needs that because that's where it gets basic communication skills, world knowledge, and in many cases, its reasoning capability is a function of the LLM. There are reasoning models that work really well. So you can't really build agents without LLMs. They might be large language or small language models, but you do need them, and they are one of the four fundamental components of an agent. The second part of an agent is what we just talked about in the previous prediction, which is that in addition to world knowledge, agents benefit by having specialized knowledge. And that specialized knowledge is expressed in some cases as agentic RAG, but in many cases as things like knowledge graphs, where you populate it with very specific information, but you don't just give it an information set, you give it a graph that it can actually manipulate, and it can use not just to see specialized information, but to actually develop skills around that specialized information, pathways through the knowledge graph that help it repeat tasks. And sometimes we call that short and long-term memory, that it can actually keep state over a very long period of time by instantiating what it's learned in the knowledge graph, not in the LLM. The third component, though, is that, and we talked about this earlier also, is that agents, this kind of system, need to perceive the world around them, meaning they have to access external data, and they need to be able to do things, which means they have to be able to use tools. MCP becomes the protocol of choice to do that. So in addition to having large language models and knowledge graphs, MCP, or a like interface that allows them to access external data sources and interact with tools, is a critical component of this system. And then the fourth component, which is probably the most important in my view, is agents can talk to each other. Unlike traditional AI tools that operate in isolation, agents actually do better when you put them into an ensemble and you actually allow them to work together, that they bring different skills and they collaborate. And the reason you do that isn't just because you want to distribute the work, it's because it allows you to start to introduce behaviors like consensus into their decision making. And we actually did some studies where we've seen that when you take a collection of agents, an ensemble of agents, and they share a base truth with a common knowledge graph, the knowledge graph is truth, the LLM is opinion, and the agents all share that base truth. If you give them a governmental system, because ensembles, you tell them, is this a democracy, an autocracy? How do you want these systems to behave? If you tell them that consensus matters, if one of the agents and their LLM start to hallucinate and do crazy things that are inconsistent with ground truth in the knowledge graph, the other agents ignore it. They don't let it impact the outcome. It's like, imagine you take 5 people in a team, and one of them is absolutely nuts and starts saying crazy things. You have countermeasures. You agree collectively, that's a dumb idea. We're going to do the right thing. And so we've seen that behavior in agent ensembles. Well, that brings us to that fourth component, which is they have interworking protocols. And that's where agent to agent or A to A primarily lives. And it's an ability for you to actually express communication between agents so that they can work as teams, they can delegate tasks. And that's incredibly powerful to go after these bigger sets of activities that we want to pursue beyond just single process, single tool. So that picture, and I'm sure we can throw it up on the screen or something, and you can see it, has become incredibly helpful to help people understand these are not just an LLM. These are these four capabilities: general world knowledge and communication skills, specialized knowledge and state memory, the ability to perceive and act in the real world, and the ability to communicate together in ensembles. When you take those four capabilities, put them together, you have an autonomous agent. And I think that's going to be kind of a fairly enduring definition that most of the world agrees with. And just caution, there's a few people who think all that stuff can just be done as magic inside of the black box of magic called an LLM. We disagree.